Example number 8. 1 plus sine x degree upon 1 minus sine x degree. Here there is a numerator upon denominator, so we apply the quotient rule. But there is one problem. Here is x degree and we have to differentiate with respect to x. So we discuss about x degree. We know that for converting degree measure into radian measure, we multiply by 1 upon pi upon 180. So we multiply this x by pi upon 180. So we convert this x degree measure into radian measure. Let us consider this function with y sine x degree upon 1 minus sine x degree. So differentiate with respect to x. dy by dx equals to quotient rule 1 minus sine x degree bracket square, this v as it is, ddx of u means 1 plus sine x. This is a minus sign here, so 1 plus sine x degree upon ddx of 1 minus sine x degree. This 1 minus sine x degree as it is, and we have to convert. If we have to differentiate with respect to x, then convert this x degree into radian measure. 1 plus sine x degree means x pi upon 180 minus 1 plus sine x degree ddx of 1 minus sine x degree means x pi upon 180 upon 1 minus sine x degree bracket square as it is. This term is as it is. We differentiate with respect to x here. So differentiate with respect to constant term. Constant term, derivative of constant term is 0, and derivative of this sine x. Sine x means cos of x pi upon 180. Derivative of sine x means cos x. But here there is a terms in x, so ddx of x pi upon 180 minus sine as it is 1 plus sine x degree, and derivative of this term is this minus sign. Derivative of this term is this minus sign and this minus sign, means minus sign as it is. Derivative of 1 means 0, this minus sign as it is, and derivative of sine x means cos x. X means x pi upon 180. So we again differentiate this term x pi upon 180 with respect to x upon 1 minus sine x degree bracket square. 1 minus sine x degree, this cos of x pi upon 180, and this derivative of this term is into pi upon 180 minus 1 plus sine x degree. This minus and this minus is plus, so cos of x pi upon 180, and derivative of this term is into pi upon 180. 1 minus sine x degree bracket square 1 minus sine x degree. In the numerator, here there is a common term cos x pi upon 180 into pi upon 180. This is the common term in both term. So we common this term cos of x pi upon 180 into pi upon 180. Pi upon 180. So here, if this term is common, then the remaining term is 1 minus sine x degree. After that plus sign, and here this term is common, then 1 plus sine x degree here. So upon 1 minus sine x degree bracket square. Here sin x, sin x degrees cancel. After that, here the minus sin x degree minus plus sin x degree cancel. Here there is 1 plus 1 means 2 into pi upon 180 into cos of x pi x pi upon 180 means x degree here upon 1 minus sin x degree bracket square. So after dividing this, we get pi into cos of x degree upon 90 into 1 minus sin x degree bracket square. This is our dy by dx. Next example, let us consider this example with y equals to cot of log of x upon 2 minus log of cot of x upon 2. Differentiate this with respect to x. Dy by dx equals to cot x, derivative of cot x means minus cosec square x. So here derivative of cot this term is minus cosec square log of x upon 2. Cot x, derivative of cot x is minus cosec square x, and here there is a term in the x, so differentiate this term with respect to x again. Minus derivative of log of x means 1 upon x, log x means 1 upon x, sorry, cot x upon 2 into ddx of this term cot x upon 2 minus cosec square log x upon 2 as it is, and derivative of this term is 1 by 2 as it is, and log of x, derivative of log of x means 1 upon x minus here 2 upon cot x, 2 upon cot x, and ddx of cot x means minus cosec square x, cot x, derivative of cot x means minus cosec square x, and upon 2 as it is. So we cancel this 2 minus cosec square log of x upon 2 upon 2x minus minus plus, and 1 upon cot means tan x into cosec square x. This is our final answer, dy by dx. Our next example is e raised to the power 2x minus e raised to the power minus 2x upon e raised to the power 2x plus e raised to the power minus 2x. So let us consider this term with y and differentiate. First of all, we arrange these terms. Here e raised to the power 2x minus this e raised to the power minus 2x is written as 1 upon e raised to the power 2x. Also e raised to the power 2x plus 1 upon e raised to the power 2x. After cross multiply, we get e raised to the power 2x bracket square means 4x minus 1 upon e raised to the power 2x. Here also 4x plus 1 upon e raised to the power 2x. Here 2x e raised to the power 2x, e raised to the power 2x cancel. We get final term e raised to the power 4x minus 1 upon e raised to the power 4x plus 1. This is our original y, and we differentiate this term with respect to x here. So we get dy by dx, numerator upon denominator, so we use quotient rule. e raised to the power 4x plus 1 bracket square e raised to the power 4x plus 1 as it is into ddx of e raised to the power 4x minus 1 minus e raised to the power 4x minus 1 into ddx of e raised to the power 4x plus 1 e raised to the power 4x plus 1. Here derivative of e raised to the power 4x minus 1 is derivative of minus 1 means constant term, derivative of constant term is 0, and derivative of e raised to the power 4x means e raised to the power 4x, and also derivative of, we have to find derivative of 4x means 4 minus e raised to the power 4x minus 1. Here also derivative of plus 1 is 0 and derivative of e raised to the power 4x is e raised to the power 4x, but here e raised to the power x is e raised to the power x, but here there is a term in x, so ddx of 4x e raised to the power 4x plus 1 bracket square e raised to the power 4x plus 1 as it is, and derivative of this 4x means 4, so into 4 into e raised to the power 4x minus e raised to the power 4x minus 1, and here this term is as it is, means ddx of 4x is 4 and e raised to the power 4x as it is, so e raised to the power 4x plus 1 bracket square. Here there is a common term for e raised to the power 4x, so we common this term in the numerator 4 e raised to the power 4x, and after taking common we get e raised to the power 4x plus 1 and multiply this minus sign to the bracket minus e raised to the power 4x plus 1, so e raised to the power 4x plus 1 bracket square, cancel e raised to the power 4x, this plus minus sign, so 1 plus 1 means 2, 2 means 2 into 4 means 8, 8 e raised to the power 4x upon e raised to the power 4x plus 1 bracket square. This is our dy by dx. Let us denote this example with y, and here we know that there are two terms in the numerator and denominator. We know that 1 minus cos of theta and 1 plus cos of theta. We learn this formula. Therefore 1 minus cos of theta, 1 minus cos theta is 2 sin square theta by 2 and 2 cos square theta by 2. 2 cos square theta. But here theta means 3x.